Hey guys, last time I was setting up my Debian installation in this laptop of mine, and I did pretty much customization and installed so many extensions and removed all the bloatwares which I had not shown in my last video, but I did it anyway. And then I changed the wallpaper to this cool one as well. So the customization and everything is almost done, and today we'll be installing the Nvidia drivers. We'll be needing it to do stuff like using TensorFlow GPU and then playing some games, and then the overall stability of the system even improves if we use Nvidia drivers, as it is the dedicated driver that is provided. It is the dedicated GPU that is in my system. But installing Nvidia drivers is not an easy task to do, at least in Linux distros and Linux environments, because Nvidia itself is a commercial company. It creates proprietary softwares which are not so free to use. That's why the compatibility between Nvidia drivers and Linux is not so great, and basically Nvidia is not even trying to do much about it, so I despise them for that. But anyway, there are a few ways to install Nvidia drivers in the Linux environment. As of now, we can actually go to the website and search for a driver specific to our GPU card, and then download a .deb package and then install it via dpkg. But the issue is that they have a proprietary software that has no signatures on it, so we actually have to generate a pair of private and public keys and add them to mockutil, and then we also have to manually sign it while installing the .deb package via dpkg. So that is a long procedure, and even it fails. I tried to do that so many times, but I failed each and every time. I don't know what I was doing wrong. The only workaround I got through was to install it via the steps that are mentioned in the official Debian package of how to install Nvidia drivers. Debian website. So I'm gonna follow that. I installed the Nvidia drivers last time using that tutorial only. So this time also I'm gonna do the same. Let's just search for Nvidia driver installation for Debian. Here it is. Let's just firstly do this one to detect if the GPU card is being detected by the software or not. Seems like I'll have to install it as well. The Nvidia detect script found in the Nvidia detect package in the non-free section. Let's see just by installing this if I have the non-free section in my sources or not. Sudo apt install Nvidia detect. It is unable to locate, which means that the non-free source list is not in the source package, the file that contains those sources, which apt uses to find and install packages. So it seems like I'll have to add that first in order to install even this basic utilities. I think even the Nvidia driver itself is in this non-free source list only, so I'll definitely have to do this. When I open that link, it seems like it redirected me to here, but there are no tutorials for how to add that. I know I have to append, but I don't know the path of that file. I know, but I don't remember it, and moreover the exact those HTTP links and src links. I don't remember them as well, so I'll just ask ChatGPT. How do I add non-free to source list in Debian? Sources.list file. So I'll have to open this. And then I'll have to add the non-free repository. So these are the non-free repository themes. You will see a line that looks like this. Yeah, there are lines that look like that, I guess. Bookworm main. No, there are no lines that look like that. Let me just copy this and tell ChatGPT that these are the lines that are currently in my. These lines are currently in my sources.d file. Actually, the thing is, people get scared from using Linux and their derivatives all the time, but I don't think it is so tough. Like maybe if you have been using Windows for a very long time, all your life, and never ever got your hands on this, maybe initially you will find it tough, but it is not so tough. Yeah, like you are doing things in GUI when you're using Windows, and the same things you are doing in CLI, but the thing is, you are not like coding and doing all those fancy things. These commands are so much simpler. You just have to get used to them. I don't remember them often, but there is always an help available on the internet, so you can have that. So ChatGPT is saying to add non-free and contra repository along with non-free firmware lines you already have. Follow these steps. Modify the existing lines. Update the lines you source file and include contra and non-free. Here is modified content. So seems like I have to add these. So let me just remove these, and then I'll just paste the thing I just copied. I didn't research enough to find if there is an easy way to delete things in the terminal, in the nano. So I just do this the hard way. Save, and then yeah, it is done. I just have to update the package list now, and then maybe I'll get those Nvidia detect things. Sudo apt install Nvidia detect. Yeah, it is found now, and it has been detected. Now let me just try the Nvidia detect command. Yeah, so the Nvidia GPU is detected. It is a VGA compatible controller. This is the module that is controlling the GPU. This is the code name of the GTX Nvidia GeForce GTX 1650, and my card is supported by all driver versions. Your card is also supported by Tesla 470 driver series. It is recommended to install the Nvidia driver, but I think just using the command sudo apt install Nvidia driver is not gonna fix my problem, mainly because the modern laptops, they all come with secure boot enabled, but with secure boot enabled you are actually able to Nvidia driver is not compatible with your laptop that way, because Nvidia driver, as I said before, is a proprietary software, and it does not comes with in the signed form. So if you do not have secure boot or it is not enabled, you will work fine, but Nvidia driver does not work that way with secure boot enabled. So I'll have to find a way that is also listed in the official documentation section. And let's say I want to install this one. install installation. Debian unstable SID. No, we are not on SID. We'll have to find Bookworm. Here the Bookworm, and oh, so this was already there. I just had to find a bit more. Then we'll have to do this. The DKMS actually builds the Nvidia module that is specific to our current kernel, but it is not gonna work if we have secure boot enabled. It is just gonna reject the installation. So I'll have to see here, note this about secure boot. If you have secure boot enabled, that is the case with most of the laptops and systems that come nowadays. You need to sign the resulting modules. Detailed instruction available here. So I'll have to also follow this, but let me first just, I don't know if I should do this first or this first. Let me try this one. What are the things that are mentioned here? Secure boot enabled, finding Debian's SP keys, generating a new key. Yeah, so we have to generate a new key, a pair of new key which contains a public and a private key. They both are used to sign any unsigned software packages that comes, so that they can be used along with secure boot enabled systems. Ubuntu has chosen to place their auto generated mock at this. So let me just check if I have a pair of generated keys or not. Cannot access, so I'll have to go to sudo. Oh, seems like there is no such file or directory. So we do not have any our package did not come with pre-existing private and public keys. So we'll have to create a custom mock key. We will store it here only because that is the tutorial stuff, and it is easier to just follow along and not modify things for the sake of simplicity. So I'll just make this directory. So it says permission denied, of course, because I'm not in sudo, and it is now created. And now I'll have to go to that directory. Oh, I don't have to use sudo with the cd command. Yeah, I'm now in that directory. Sorry for the lag. I don't know if it is being recorded or not, but it lagged because the electricity connection just was cut off. I'll copy this and then paste this over here. This uses the OpenSSL software to create a new pair of keys. It uses this encoding. I don't know what this is. This is the name of the private key, mock.priv, and then this is the public keys extension. mock.der is the public key, and its validity is supposed to be 36,500 days, which means basically 100 years. So it is basically gonna outlast me if I don't reset my laptop again. And let's just keep this as it is, or maybe modify the name as, nothing generic. Like this key is gonna be used every time DKMS signs any package. DPKG signs any package. So it is not gonna be specific to Nvidia driver. This is a one-time setup that I have to do. So it is gonna be the same for everything, and I don't think I should write the name this as Nvidia drivers. Generic is good enough. So permission denied. Yeah, I have to do this in the sudo mode again. Sorry for that. Yeah, so it is done now. Pair of keys are generated over here. If I do ls, maybe I'll see mock.der and mock.priv. Those keys are generated. Now I'll have to do this, I guess. so that mock util gets import. No, this is something else. I don't know what that is, but it is something else. Let's do this again in the sudo mode. That is done. I think it is informing the system that these keys are generated. I don't know. And then I have to do this. Just leave the comment section out. And what this will do is that the next time I reboot, it will ask me to enter, even entering this command will ask me to enter a password that I'll have to use while rebooting next time, and the system will ask me for a password in order to enroll that key to the system, because these mock utils and all the stuff is just a tool, but the actual secure boot and those implementations are done at the BIOS level, you know, so we have to do that from there only. So here it asks me for a password and I entered it. Yeah, so it is done, I guess. At next reboot, the device firmware should launch its mock manager and prompt the user to review the new key and confirm its involvement. So let me just reboot and I'll do the stuff that is required over there, and then I will come back and do the rest of the steps. So let me just stop my recording for that time being. The mock keys were successfully added to the mock manager, and let's now continue with the rest of our steps in order to install the Nvidia drivers. To verify the mock was loaded correctly, let's try this command. Let's see if the mock was actually loaded correctly. So it will ask me for a password, of course. It's already enrolled, so it seems like the loading procedure was done correctly. And now we'll move on to the adding these keys to this environment variables, such that in order for DKMS to automatically sign kernel modules, it must be told which key to sign the module with. So this is done by adding two configuration values to this one. So I'll just open this and sudo nano and paste it. It does not exist. Is DKMS even there? Let me just ask ChatGPT how to know if DKMS is there. So I'll do this. So it is not there, it seems. So I'll have to install it, and let's do this. Just get downloaded and now installed. Yeah, it is installed now. So this directory should have been made now. Now let's try this one again. Yeah, so it is here now. So now I'll have to add this value to the mock signing key and the mock certificate. So here it is, mock signing key var lib. Let me just copy paste that. Here goes the mock signing key, and this is the mock certificate. So I'll delete this and then paste this. Yeah, it seems like we have assigned both the attributes their proper values, and now I'll just uncomment these two lines so that it actually works, and then save and then exit. So So everything is done now, I guess. The secure boot should now be bypassed. It is not actually being bypassed. We are doing the stuff manually, and let's just install the Nvidia drivers now in the sudo mode. Yeah, seems like we have done the stuff. It will now be downloaded and then installed. And while this is being done, we will then also have to install CUDA and cudnn drivers specific to the environment that we'll be working upon. So I'm currently training efficient date model that particularly works with older Python and CUDA versions. So I'll have to probably go with Python 3.8 along with CUDA, older CUDA and cudnn versions. The actual details can be found on the TensorFlow installation page, I guess. It is actually there in the build section. Yeah, this is the official TensorFlow page, and in this section Linux here at the bottom will probably get, yeah. So actually the last time I tried doing things with this one, but it was not compatible with the object detection API that comes with the the efficient date models. So, and then I tried other versions too, but that didn't work either. So the first Python version that actually worked was 3.8, and it is the latest one, so I'll go with it. And the TensorFlow 2.13 comes with works best with 3.8 and with cudnn 8.6 and CUDA 11.8. So we'll install all of them one by one, but let's see. Conflictly, the free currently loaded and conflicts with the just set of switches to reboot the machine once the installation has finished. So I guess I don't have to manually disable the Novio kernel module. As it says, I just way to fix is reboot the machine once the installation has finished. So I will just do that, and okay. Not creating, could not execute. Seems like we got these two things because the Novio was enabled. Novio is a legacy GPU driver that is used by default if no other drivers are installed, because these, as I said so many times, that Nvidia drivers are proprietary softwares. So Linux prefers Novio driver to be installed by default. So what it is basically doing is that it is signing and creating a module specific for my kernel in order to install this. This is being done by the DKMS software. Meanwhile, let me just ask ChatGPT what is the meaning of these. So I got this last time as well. Now, and the thing is that these are warnings, and your drivers are not caused any Nvidia SMI is yet another command to check bad when you Nvidia driver update your init RAM FS, and then see all these warnings. So let's just see this. But these packages are nowhere to be found. I tried to install it last time as well. It has some of them were found, some of them were not. But do understand that this is not the CUDA that we are I'll probably have to reboot, so let's just remove the CUDA package, reboot and stop the record. That will actually work. And these are two things. Seems like the recording software OBS is also utilizing some GPU, and then there is Xorg, that is just the desktop environment that I'm using. It is using minimal amount of memory, so it is fine. The voltage is being shown, the temperature and everything is being shown. So seems like we have done this one, and now let's move on to the next one. For the next step, we are going to install Anaconda. Anaconda acts as a container. It provides you with various environments to actually contain the packages and dependencies, so that they do not conflict with the actual system packages. Like if you do all this stuff without Anaconda, you are doing it system wide, and any other dependencies that was Python dependency that was being used by the system will obviously get affected by it too. So it might sometimes cause compatibility issues and stuff like that. So let's just do it in a separate environment, so that nothing gets affected at all. So for that we are going to use Anaconda, and I guess I've already downloaded the .sh file for that. Yeah, here it is. So we'll just now follow the official documentation where the tutorial for installing Anaconda on Linux is being given. Installing on Linux, yeah, here it is. So we also have to install some dependencies before actually installing Anaconda. So I'll do that. Seems like everything was already installed. You might not have the dependency installed, so you must do that too. Now the installation stuff starts. So this is basically curl command. This curl software does not come pre-installed with the Debian package, so you probably have to sudo apt install curl as well. But I'm not gonna use curl because I've already downloaded the latest Anaconda installation script from here. So I'll skip this one and then leave this integrated stuff as well, and then we just have to use bash command to execute it. So I'll cd to downloads and then list the files and then just run them, bash and this file name, the script. So just enter, and then these agreement stuff will come. Just press the down arrow button again and again. Yes, it is done now. So I don't know why it happens, but whenever I reach the end of it, it kind of gets stuck. Like if I click enter, it should move away, but it does not. So I'll just type yes, and then I don't know what happens, and it just works. And now, do you accept the license terms? Yes, of course I have to, or else it will not let me install it anyway. And another thing to remember is that never install this Anaconda in your root directory, or run the installation script as sudo, because yesterday I did that, and that installing Anaconda actually changes the bash rc file, which is used to access your sudo and su and everything in your terminal. But it actually, I think, misbehaved and just added the Anaconda stuff over there in the bash rc file and removed the actual directories like sbin and local user and all that stuff, so that you cannot even access your sudo or su modes. So remember to not do that, because I had a pretty tough time fixing all that stuff. I had to use another Debian installation to see what actually resides in those files, and then I had to copy paste that stuff. So you're gonna face issues if you do that way. So just install it without sudo. That is what I wanted to say. Now just press enter to accept the default location. It is fine. So this is where Anaconda is being installed in the prefix. Now the files are being extracted. Let's just wait a while. It has been extracted, and now it will ask me if I should go with automatic Conda activation in all terminal launches.
so that whenever I open, if you have ever used Anaconda software, you will see that when the Anaconda software is activated, it actually there comes a base and inside parenthesis word written behind your username and stuff. So that means that the Anaconda software has been activated, but the software actually gives you an option to manually activate it, but I would like to have the base stuff going on all the time, because I have no issues with that. So I'll just type yes, and yeah, installation is done. Now I'll have to open the current shell, or maybe just reload the bash rc file in order to for the changes to take effect. Yeah, so as you can see, the base is coming now. Seems like the installation was perfectly done, and now we have also installed Anaconda. So now it seems the stuff that is left to do is to install the CUDA and cudnn drivers, but installing them is not an easy feat either. Now we are gonna use TensorFlow 2.13 GPU version. So we'll have to make a Python 3.8 environment. So let's just do that first. Conda create name. What do we keep its name? You can keep it as TensorFlow GPU, and then we are gonna specify the Python version that we want to use with it. So it is going to be 3.8, and then just hit enter. So that environment with Python 3.8 and its dependencies get generated. These are the dependencies that are going to come with this environment. They are now being downloaded and stuff. Yeah, so the environment has been made, and now I'll just copy paste this command to activate it. It is activated. You can see the base is now changed with TF-GPU, meaning that TF-GPU environment is now activated, and any other dependencies or Python software that I install now in this are going to be containerized inside this environment only. So we are gonna do that. And now let's just move on to the cudnn and cuda installations. So we are going to use CUDA version 11.8. So let's search for that. It was on some website called Nvidia. Yeah, here is the CUDA archive. I had searched it before, and here we have to find CUDA version 11.8 it was, yes. So we'll just install this CUDA. It will ask me for my software specification and then just give me some commands to install it, and I am using Debian. Let's do it for 11 only. It is not gonna affect much Debian 12 and 11 stuff. It is gonna work fine, and I'm gonna install it locally. So I'll use this wget command to download the package. So, and I would like to do that in the downloads. Yeah, it is already downloads. So let's just have this, and then we'll have to use the dpkg manager again to install this, and then we'll sign this package with the GPG keyrings, and then we'll have to add the contrib repository, and then we'll have to update it and update the package list, and then finally we can install CUDA. So it's a somewhat pretty long process. So let's wait for a while, and meanwhile let's also search for the cudnn software, that is 8.6 cudnn. Yeah, installing.
you should get the link somewhere over here. cudnn downloads Linux target ARC distribution. This is cudnn 9.2, but we would like to go for previous releases. We have to use cudnn 8.6. Seems like this is the one. Here it is. cudnn 8.6 is over here for cuda 11.x and cuda 10.2. We had downloaded 11.8, so it will work for 11.x. So 8.6 and 11.x, this is the one, and we'll have to open it, and then we'll just use the local installer for Debian 11, you know. And seems like I'll have to log in order to install this, I guess. Is there any other way? No, seems like there is not. So I'll just pause the video while I do this stuff. Yeah, so seems like we have successfully logged in, and now let's search for the 8.6. Yeah, this was the one, and then just install this. I mean download this. So it is being downloaded. Yeah, the recording is fine as well. And then in order to install this, I can just maybe follow the installation step that comes while executing this .deb file, I guess. And seems like cuda is also installed now. I mean the package is downloaded now. So let's continue to the next steps. That was to install this one with this command, and it is being installed. This I actually is used to install a .deb package via dpkg. So now it says that the is installed, and I have to use this. So I can just do this, and now it is signed. I could have also done this, but they're the same thing essentially. And then I'll have to add this to the repository. Yeah, so the adding is also done. Now I'll have to update my package list. The package list is also updated. Now I'll just have to install this one via this command. The -y stuff automatically bypasses the yes or no thing that I have to do. The time when it asks whether you want to actually install the package, so it bypasses if you write that just in command instead of typing y again. So now it is being installed, and seems like our cudnn file is also downloaded. So now in order to install this, I might have to take help of YouTube. How to tensorflow in WSL2, because this is the keyword that I last used in order to get that video. That video was very much informative and to the point. It just had a whole screen, a whole page where the commands were written step by step in order to install this. That was the most easiest installation that I that I had ever done for this software. Let's just add this keyword YouTube. Yeah, seems like this is the one. Yeah, here it is. Here are the commands. Yeah, so CUDA is finally installed, and now I'll have to install the cudnn file as well. We just have to use the same sudo dpkgi command, and then the file name. Let's firstly find the file name, then sudo dpkg-i, and then the file name, which is this one, and copy and then paste. So it is being unpacked. Then we have to sign this. We probably get this command over here as well. Yeah, so just copy and paste it over here. It is signed now. Now we'll have to update the package list. Sudo apt get update. The updates are being done, and now I'll just have to install these dev sample and stuff. But actually what will cause me issue is that I'll have to manually find the replacement for this XX and Y. So I'll just ask ChatGPT for the commands to install this. How to install cudnn in Debian. Download, we have downloaded. Install cd, install libraries. Oh, seems like we'll actually have to replace X, Y, and Z with those stuff. So maybe if I give it the name of the package that I just downloaded, it might be able to give me the exact commands that I need to execute. This is the installer name. Give me the commands to install the package. Here it is. I just had to execute these simple commands. Oh, it is a pretty big software, I guess, of 2500 megabytes. Basically, cudnn stands for CUDA neural networks. It is used to, accelerate the training process with neural networks on GPU, with Nvidia GPUs specifically, with CUDA enabled and all that. So seems like we have installed CUDA, we have installed cudnn, we have installed the Nvidia drivers, even we have installed Anaconda and activated our GPU environment. Now we just have to install TensorFlow, because everything else is done. Yeah, so pip installed TensorFlow should do the work, because specifying GPU in this command was actually deprecated within previous versions. So I'll just have to run this one, I guess. It is collecting that, and then we'll also run a demo script in order to check whether the GPU version is running or working or not, so that I can actually train on GPU instead of training on this. Last time the last time I was installing TensorFlow stock packages, I was running out of the cache memory, because the cache in Linux systems are actually stored in temp partitions, but my temp partition was only 2 GB large, so I had to temporarily export the temp dir to some another directory, so that it can be used temporarily for installing this, and then I had to do all that stuff. But now, as my temp partition is already so big, so I don't have to worry about that stuff. So TensorFlow is now installed, and so I guess everything is installed now. The stuff that I was trying to use should work now. I'll also have to install efficient det and stuff. So how did I install that actually? Let's just ask ChatGPT to use efficient det. Yeah, actually I had to download the efficient det models and all that stuff. Yeah, it was pretty big procedure. D0 with TensorFlow 2.0. The implementation of efficient det models with TensorFlow Lite is much easier as compared to the actual jumbo version like 2.0 and stuff. I'll have to also install some extra libraries. Clone the TensorFlow model which contains efficient det implementation. I already have the dataset prepared, as I used it the last time I was doing things. I also have the config file. And then I'll have just to train the model. So seems like we'll just have to clone this one, or maybe I have it cloned, I don't know, let me check it. Oh, seems like we have all the necessary models and stuff already here, and maybe I just need to run the train command in order to start the training. Is actually the script was something else. It was models, then under research it was under, what was it under? TF main 2. Let me just ask him. I want to use TF main 2 script instead. Where can I find the script? Detection. Official within detection.
Seems like it is not over here. Maybe it is over here. No, these are just constructor files. What is this one? Actually, this is not the one I was looking for. I want to use a detection model, or maybe I can just search it over here. Detection. Maybe I should search the file name instead. TF main. Maybe it was TF underscore main. Maybe it was TF2 underscore main. No. These are checkpoints. This is the data set here, annotations are there in .json format. The training images are over here and the validation images over here, and the trained folder is empty because I have not trained anything. This is readme. This is the configuration file having everything that I need to give to the training script. But I don't seem to find the training script anywhere, I guess. Where it should be. It is not over here. Seems like it. Then where it is? It's not in official, it is in research. Object detection model. Yeah, I guess I finally found the files. Here it is. So model lib, model main. I guess I'll have to use this one to train this. Let me first check its content and syntax in order to. Yeah, this is it. This is the one that I am going to use. Let me just copy its path. Copy and paste. Yeah, so add Python over here, or maybe I should cd out of here and go to the dev directory and then to the avd underscore ftech. Yeah, so here I'm going to run the script from here only because all the config files and stuff are stored here, and I'll just cd into that directory where the training script was actually residing, so that the configuration remain unchanged and I don't have to read out the directories and all that stuff. Just copy this and run this via this command.
all these things are already specified in the config file, so I don't need to do this individually, and I'll just use Python. My bad. This, and I'm already over here, so I'll just delete the path behind it, and then I'll add the file name. The file name was this, and paste it over here, and then I'll add some parameters like what were the parameters? Like pipeline config path. Yeah, I have to specify this. I have to specify this over here, and the file name is actually, let's just move it out of here, and the file name was pipeline.config, so I'll append it over here, pipeline.config, and then I'll also add another attribute to use the checkpoint. This is the stuff, model dir. Yeah, so paste, and I'll have to use checkpoint slash ckpt0, or maybe not. I'll just have to specify the directory, I guess, and it might detect appropriate checkpoint automatically. Yeah, so everything should be fine here. Actually, the electricity just got cut off again, so I think if I start the training stuff right now, things might go out of hand, so I'll just pause it for a while and wait for the electricity to come back again. Yeah, it is lagging a lot, like a lot. Yeah, so finally the power came back, and actually I didn't saw, neither did I remember, but the training command was actually there already in my, in my folder in this readme.md file. I didn't even care to check. This is the one, and I have just copied it and pasted it over here, and this should do. Let's see if there are any libraries missing. No module named tf_slim. Let's see, where is this slim thing? Our training script was in this, then in this, and then in this, and here was the model main. Let's go tf2. I hope this was the one. Yeah. So here the error says that in this line 34 is fine. Object detection, no module named tf_slim, eval util
Seems like we'll have to finally ask ChatGPT only. Indicates that the TFSlim model is not installed. It was always need to install a TFSlim package. pp install tf_slim. Seems like this is another package that I have to install separately. Yeah, so it is installed now. So let's see if this works now. Cocoa tools, we have to install that as well. So let's just type pip install cocoa tools. Yep. Yeah, so it is done again. Now let's try again. New model named Elvis. Seems like we have to install this one as well. Elvis. So that is done too. Now let's try again. Yeah, SciPy. Forgot. It is also done. TensorFlow IO. This is probably the last package that I will have to install, I guess. I don't remember exactly. Yeah, seems like it. Yeah, so it is also done. There's so many modules missing. I guess I'm doing something wrong. Yeah. Seems like I'll have to install that, detection API in order for these packages to be installed automatically. Let's see what ChatGPT has to say. The official does not install it. Do I have to install the object reduction API too? If so, how do I do that? So need to install. Yep, seems like the problem was right there. So we'll have to firstly install this protobuf compiler so that the installation can be done, because the installation requires a protobuf file, and the protobuf file requires a compiler to actually get generated. So we'll have to firstly install this one, and then ChatGPT says that we'll have to clone this one, and then we'll have to compile the protobufs. So this is actually in the models and then research, and I guess we already have that. We already have that in our folder, so we'll not download it again. We will just go to the path as said by it, models and then research. It seems like models is not there. Research, and the research also doesn't seem to have that protobuf thing. Let's see what is in this by cloning this. So let's just clone this. It is cloning, and then we'll have to go to this directory. Seems like the download speed is pretty much slow. Yeah, so it is cloned. Now let's go there. Now let's see for ourselves what is there. Models, and then research. Seems like this research and this research are the same. Am I right? That seems like it. So seems like we have just wasted out some of the data by downloading this again. We just have to use this command in the research directory itself. So let's go there. Yeah, let's remove this one first. There's no need for this pointless ambiguity. Delete this one, and then go out of here, and again. Now let's go to the first, then go to _f_det. I type something wrong. Oh shit, my bad. cd dev, now this, and now cd, let's see first what is there. Cd into this, and then cd into research, and finally we are here. So now we will copy this one and just compile the protobuf. Seems like it is done. And now source the file, add the research and stream directories to your Python path. So you can do this by following this, and then source the file to update the current session. Install the required Python packages. Test the installation. So I guess we'll first do this testing stuff, then we'll try to do this on our own script, that is the tf main2 script. So firstly let's do this, and then let's reload the terminal by this command. That is done, and now let's install the required Python packages. So seems like there is no requirements for txt. tfslim is installed now, and now let's try to run this. No module named tensorflow. Oh, my bad, I didn't activated the activate conda activate TF GPU, and now let's try this one again. Seems like official is still missing. Let me ask it. There's no requirements.txt. You can manually install the requirements for the install protocol compiler, compile the protobufs, add the object to the Python path. You can also add this line to make it persistence. Install required Python packages, and then I have to test it. Let's activate the environment, and now let's install all these packages if they are not installed. I think this Jupyter and stuff were not required, as I normally don't code the machine learning models in or any scripts in Jupyter Notebook. And then we'll have to test this one again. So right now we are in research. Let's check research, and then object detection, and then builders, then model builder, builders, and then model builder. Where is model builder? Here is model builder. So seems like it is there. No module named official. So this seems like we'll have to use the cloned one, because this one doesn't seem to work. It was working last time I checked, but it is not working right now. So I guess we will restore this one, and then delete this one. Now let's try those commands again. CD models research. Yeah, so we are in, and now let's compile the protobufs. And let's add this to the path. Source basrc. Activate TF GPU, And now let's try this one again. Official module is still not there. Where are we detecting this error? File home extractor.py. Yeah, so I searched, I asked ChatGPT that the error is still prevalent. So ChatGPT said me that I will have to install this TensorFlow models repository in order for this to work. So let's try if this is there. Yeah, seems like it is there. Clone the TensorFlow models repository. I have already done that, all of that. Add to the Python path. Already done that. Then cd official pip install -e. First let me check if it works just by doing this. Oh, seems like it works. Oh, so finally the training has started. My GPU is being used, and I think the memory is being allocated right now. Yeah, so the test was perfectly done, nothing went wrong, and I guess I should be able to run my own script right now. So let's move back there, and here is that script, I guess. Yeah, I'll have to execute the script from here only. So let's see what was the script. Yeah, this one. Can't open file. Yeah, so actually the models will be replaced with this new one. I'll have to remove this because that was some different directory and now it is different. Yeah, so seems like the training has started, and there are some warnings. I'll have to fix them one by one, but for now I guess everything is fine. The training is working, the GPU is being used. If you ask me how I know GPU is being used, see here, compiler cuda GPU executor. If the CPU version was being used, this statement would not have been here. So yeah, I know the GPU is being used, and there are some warnings. I'll have to fix them one by one, but for now our setup for this is complete, and let's just cancel this one for now. Yeah, so we have finally completed our setup for the work environment. Everything is done, and now I'll just have to fix all those warnings and errors and everything, and optimize the script for specific to my dataset. Basically my dataset contains images of various vehicles in various conditions like day, night, and weather conditions like rainy or sunny. So that the challenge lies here only, because the traditional training datasets are not designed in such a way that they can such a way that the model could be trained and still be able to detect vehicles in such a condition, such a harsh condition. So it is much difficult for the model to understand and
identify each of the boundaries, those textures and everything in such a data set. So the challenge lies there. We are using a much diverse data set, so I will try to optimize the code and everything, or maybe incorporate some extra functions to improve my map scores and F1 scores and all that. So this is it for now, and I'll see you in the next video. Bye.